We're going to start out by launching the Comm App application using the desktop icon that was created during the installation process of the application. Once the home screen displays, we're interested in the automated option, so we're going to select the automated view close button. And then we're going to select the test equipment that we're going to be using to do these automation checks. And that's going to be the IFR 2947. Then we're going to select the radio type that we're going to be doing checks on, and that's going to be the CM300 version 2 receiver for this tutorial video. A visual of the receiver type and test equipment type will be displayed as shown. There is an alternate automated option applicable only to receivers connected to receiver multicouplers. Now, this allows users to do maintenance through the front TP1 test port of receiver multicoupler equipment. We will cover this option later on in the tutorial video. Before we begin, I want to go over a couple things related to the connections that we're going to be making between the computer and the radio equipment, and the computer and the test equipment. First of all, do not launch multiple instances of the same automated application. This will create problems. Prior to launching the automated application, make sure that nothing's connected to the Ethernet port on the computer, sometimes referred to as the network port. To establish communication between the radio and the computer must be configured to a unique IP address. Now, the Comm App will automatically execute a script that will configure the Ethernet port to a static IP address, so you don't have to do anything. Last, once the application launches, use a crossover Ethernet cable to connect between the computer and the front panel Ethernet port on the radio. Now, when you finish using the automated application, make sure to select the Enable DHCP button that will be displayed. This will execute a second script that will configure your network port to DHCP. This is required in order to use the network port to connect to the FAA network or to the internet. Last, I'll go over the connections to test equipment. Make sure to use a no modem RS-232 serial cable to connect the computer to the test equipment. Now, if your computer does not have an RS-232 serial port, use a port replicator or a mini docking station if one's available. Otherwise, use a USB to serial adapter, but just make sure that the appropriate drivers are installed on the computer prior to you using it. Here's the DHCP enable button that I was referring to. So we'll launch the application using the launch button shown here. Now, a script will launch to configure the Ethernet port on the computer to the appropriate IP address. Now, once the automated application launches, you use a crossover Ethernet cable to connect between the computer and the front panel of the radio. Now, once that connection is made, the software will begin to query the radio through the Ethernet port to make sure that it has a communication session established prior to continuing. So right now it says connection error, so give it a few seconds for it to establish that connection. And as you see here, now it's green and it was able to confirm that it's talking to the radio. Next, we worry about a test equipment. Now, this drop-down menu queries all of the available COM ports on the computer. One of those COM ports is being used to connect to the test set using a no modem serial cable. So you select one of those COM ports, initiate the test to see if you have a connection between your laptop and the test set. And as you see here, it says connection error. So you go and select a different COM port and reperform this test port test. And so we'll hit the start button now that we got COM9, and the result will come back to see if we have a connection between the test set and the computer. And as you see here, it shows error, so we go to a different COM port that we haven't selected yet. We'll try COM7. We'll begin the test again, and the result is positive. So now we have a confirmation between the test set and the laptop and the radio and the laptop. If you have issues with connecting to the IFR Marconi, go to page 2 and using the front panel of the test set, verify that these settings are set correctly. And again, this is using the front panel of the test set. Follow this procedure to verify that it's enabled to be configurably remote through the RS-232 serial interface. Now all the available receiver checks will no longer be grayed out, and you can begin to make your selections in accordance to the check that you want to make. And you can make individual checks as shown here by selecting the appropriate individual check, or select all receiver checks and the software will automatically perform all of the appropriate receiver checks at the same time. Now you can go through here and review all of the objective discussion and condition paragraphs, very similar to 6580.5. Now make sure that this figure here is used to connect your test equipment to your radio equipment exactly as shown using the ports that are shown here. Now the software is going to assume that you're connecting as shown on this figure, and if you don't use the correct ports, if you don't have all your cabling set up correctly, the automation will have problems. So make sure to use this figure to verify all of your connections prior to proceeding. Now if your receiver is connected to a receiver multicoupler, make sure to connect to the antenna port, the N-type antenna port located in the back of the receiver multicoupler. Now step 2 on page 2 has you select the Initiate All Test button to begin all of these checks. Now it'll perform the oscillator sensitivity, squelch, audio output, and it also performs selectivity and AVC action. Now these are optional checks that you have to say yes or no whether you want the software to include those as part of the automated checks prior to you selecting the Initiate Test button. Now once you select Initiate Test, you notice that the selectivity and AVC action options you can't change between yes I want to perform it or no I don't want to perform it. So make sure you make the correct selection prior to you initiating all the tests. Now what the software is going to do, and it's currently doing, it's going through and performing each individual check and setting up the test set in accordance to the check that is currently performing. It also verifies and if necessary makes adjustments to the setup of the radio such as enabling, disabling squelch to perform the appropriate receiver check. So really all you have to do is make sure that all your audio connections and RF connections are done correctly in accordance with the figure shown in page 1, and after that you initiate the test and the software takes over. To save time, I've edited the video, and as you can see here, we're almost done with all the receiver checks. Now, a typical receiver check will take anywhere from 2 minutes to 5 minutes, depending if you're doing selectivity and AVC action checks. When the software completes all of the automated checks, all of the results will be displayed as shown here. Now, all you have left to do is to record the measured values on the appropriate TPR form and verify that the values meet the appropriate standards and tolerances. Now, if necessary, if you need to individually adjust any specific parameter, refer to the specific receiver check of interest as shown here. Before we move on, I want to talk about the Save Options button. Click on it to look at the options. The Save Options button displays options for the user to be able to create a measured log of the measurements that were just performed. Now, it creates a daily log as a text file that is saved on the computer. Now the log saves measured values and also site-specific information, and we'll go over some of that information here in a little bit. Now the log can be useful for reviewing measured data from the radios and also reviewing what test equipment was used to perform the measured values that capture specific data. Now it also records the current radio configuration that resulted in the measured values. Some of this information such as squelch step levels, audio output step levels, oscillator frequency step levels, and so on and so forth. This information is useful when trying to recreate or duplicate anomalies in the field. Additional information that is useful that is also automatically saved on the log are serial numbers of equipment, firmware versions of equipment, when was the last time the radio went through a reboot, how long the radio has been in service. And this information is useful when trending failures, when trending performance of radio equipment. And a lot of this information is not logged on a TPR form and can only be logged using tools such as these. Last, the use of the measurement log is optional, therefore not required. On the Save Options screen, the software will give you entries that the user can use to enter facility-specific information and radio-specific information. So for example, here on the first entry, enter the facility type and ID. This gives us a record of where this equipment is operating and the facility identification code where the radios are installed. Now identify the radio by selecting main standby, ADAS emergency. Here's a timestamp of where the measurement log was created, and add additional comments. These are specific to the technician, whatever he feels will be useful in a log. And here I'm just going to put initial checks as found values. And after I enter my comment, I'm going to hit the save button. And this save button, once clicked, it'll create a text file that is saved on the computer, and within the text file all of the parameters shown here will be saved. The timestamp, the facility ID, the receiver type, the identification of the radio, whether it's main or standby, the radio type, serial number of the radio, the test equipment used to perform the checks, all of the measured values in dBm and in microvolts units, and it also, if you did perform the selectivity and AVC action, it'll show the results there. Otherwise, it'll probably just show 0. Then if you scroll a little further down, it'll show the current configuration of the radio, all the different levels that the radio is currently configured to show the performance that was captured by the test equipment. And at the end, it'll show the comments that the technicians entered. Once the log is saved, let's close the save screen by clicking on the save options button. Then let's go to the individual receiver checks to perform corrective maintenance. Now, page 1 will always show you a diagram of how to set up the test set. Since we've already established our baseline measurements, we don't have to worry about the setup. Now, we can skip to step 5, and that gives you the 2 options to make adjustments. We'll go over the manual option. Gives you the current step level that the oscillator frequency is set to on the radio, and then gives you options for you to make changes to that step level. Now, once the desired step level is displayed, hit the apply change button. This will send the new change to the radio and also automatically reinitialize the check to see what that did to the performance of the radio. Now you can continue to do this and repeat this process until your measured value is within your standards and tolerances or what you desire. Now the faster way of doing this is to automate it. You have the desired oscillator frequency that's automatically computed, and if you hit the initiate button shown here, the software will automatically continue to adjust the radio until the measured value on the test set is as close as possible to the desired oscillator frequency. And that keeps you from having to manually increase or decrease the step levels. The software will automatically do that for you, and it'll try to get you as close as it can to the desired level as shown here. When the adjustment is complete, the result will display as shown here. And as you see here, we were able to get within 4 Hertz of our desired frequency. Now what's left to do is to record the new oscillator frequency measurement on the appropriate TPR form and verify that we meet our appropriate tolerances. Next, we'll adjust our squelch level, and page 1 will show you the diagram of how to set up your test. We've already done our initial baseline measurement, so we don't have to worry about it. And we can skip to step 5. Step 5 gives you automate or manual options. We'll go over the manual first. It'll give you the current step level, and it gives you options for you to make changes manually to that step level. Once the desired step level is displayed, you will hit the apply change button to upload that change to the radio and reinitialize the squelch check to see what that change did to the performance of the radio. You can also automate this process by just entering in what your desired squelch threshold is in dBm, and it'll show you the equivalent in microvolts. Once you select the initiate button, the software will automatically begin to adjust the squelch setting on the receiver until the test set shows that squelch has been broken somewhere around -103 dBm. Now, these are digital radios, so you're never necessarily going to get exactly your desired, like -103 for this example, but you will always get at least within 1 dB of your desired level. When the adjustment finishes, the results will be displayed. And as you can see here, the software was able to adjust it within 1/10 of a dB. You never usually get this close, but in this example, of course, you did. And the last thing to do is to record your new measured values and verify that they meet the standards and tolerances. The last thing we'll do is the audio output level. We'll adjust this level. For this example, we've already got our initial baseline, so we can skip to step 5 to perform our corrective maintenance. And it'll always show the current step level, and it'll give you the options that are available for you to make changes to that step level associated with this specific parameter. Once the desired level is displayed, you hit the apply change button, and this sends the change to the radio, reinitializes the audio output level check, and it shows how that impacted the performance of the radio. And you can continue to do this and repeat this process until your desired audio output level displays, or you can automate this process. Just manually enter in your desired audio output level that you want out of the receiver, hit the initiate button, and the software will automate this corrective process for you, and it'll continue to adjust the radio's audio output level automatically while monitoring the audio level being measured by the test set, and it'll continue to adjust the receiver until it measures as close as possible to your desired level. And again, these are digital radios. You're not always going to get exactly what you desired, but you're always going to get usually within 1 dB of your desired level, which is within your standards and tolerances. Now all that's left is to record your new audio levels based on the changes on the TPR form and verify that it meets the appropriate standards and tolerances. And so since we made changes to this radio, I want to save that new measurement log. And so on the comments, I'm going to leave everything the same, but on the comments I'm going to enter that I've adjusted the oscillator frequency, I adjusted the squelch level, and I also adjusted the receiver's audio output level. And again, this gives me a history of anything that's been done on the radio. It gives me a timestamp of when it was performed. Gives me the opportunity to enter any applicable comments. I'll save the log, and what it'll do, it'll add it to the existing log that was created for today. And so as shown here, here's our new log, our new timestamp, and our new measured values, our new step values that were changed to get the new performance out of the radio. Values that we didn't modify, it just records what was last measured. And again, our comments will be added here at the end of the log. And here's the one that we previously did as part of our baseline measured values. And so here's our comment. And again, this is very useful for trending, is useful for seeing what ought change within the radio. If you click on the Save Options Close button, it'll close that option. And that's all we have for this tutorial video. Now, since we're dealing with V2 radios, once we close the automated application, we want to go to the DHCP Enable button, click on it so that it launches a script that will automatically reconfigure our Ethernet port or our network port for DHCP. Now, this is required to be able to use the FAA network or to connect to the internet using that network port. I want to quickly go over the alternate automated option. This is applicable to receiver multicouplers, Mudel receiver multicouplers, and there's an alternate launch button to launch that alternate automated application. Now, make sure to read thoroughly through all this preconditions, because not every time you're going to be able to use this alternate method. So make sure that you're familiar with the preconditions to be able to use this method. Now, one of the advantages of this new method for receiver multicoupler configurations is that you don't have to take every receiver out of service to do maintenance on one. You can use the front port of the multicouplers to do the maintenance and to connect your test equipment through there. But there are some conditions that are applicable, so make sure to get familiar with those preconditions. And so I'm just going to go through here and verify my connections between the radio and the computer, similar as we did before. So again, I'm not going to go and explain everything in detail. I'm just going to go pretty fast since we've already covered this earlier in the tutorial video. The intent here is just to make sure that I touch upon some of the differences of using this alternate automated check, and you'll see that on the title of this screen, and it's the alternate. And once we got our connections verified, again, you can select each individual check or do all of the checks at once. Now, the main difference here is that we're using the receiver multicoupler front BNC port to do all these checks. And again, here's another set of paragraphs that goes through all the conditions that are required to be satisfied to be able to use this front BNC port on the receiver multicoupler to do checks on an individual receiver. Now, all of the other receivers connected to that coupler do not have to be taken out of service. Only the receiver of interest is going to be impacted and has to be taken out of service. But again, make sure you're familiar with the conditions to make sure that you are able to use this front test port to do the checks. And again, I want to re-emphasize the importance of making sure that we use this diagram to connect our RF cables and our audio cables from and to the test equipment as shown. Otherwise, we're going to have problems with our automated checks. Now, if you go to page 2 step 2 goes over all the checks that are going to be done. Now, one of the things to note with this alternate automated check is that at any time during any of the checks, air traffic, audio, or audio from pilots may come through and interrupt the check. If this occurs, just wait for the automated checks to complete, wait for silence, and then restart your automated checks. And again, all this has to do with all the paragraphs that you should be familiar with before using this method. This alternate method of doing maintenance will have the user select whether they want to include the audio check, the selectivity check, and the ABC action checks as part of this sequence of tests. If you select yes, it will include them. If you select no, it will not include them as part of the checks. Once you've made your selections, select the Initiate All Tests button as shown here, and the software will begin to automate all of the applicable receiver checks. Then again, once you make that initialization of the automated checks, you will no longer be able to change whether you want to add the audio, selectivity, and ABC action checks as part of the automated checks that you're currently performing. Once that selection is made, it's final and you can't change it until the software finishes performing all of the checks. Now, one of the things to note here is that whenever it's done doing the squelch check, the software is going to prompt the user to bypass the multicoupler to continue with the rest of the checks, which in this case are the audio output level, the selectivity, and the ABC action. And this deals with the RF levels used to perform these specific checks, and deals with you being familiar with all the discussion paragraphs that go over why we bypass the receiver multicoupler for these checks and why we don't bypass it for sensitivity and squelch. And again, this is only applicable when using this alternate method of doing receiver checks, that is only applicable to receiver multicoupler configurations through the front TP1 port of the receiver multicouplers. Now the software is almost finished with the squelch check, and the software was going to pause performing any checks and it's going to prompt the user to bypass the receiver multicoupler, meaning you're going to recable your RF cable to the receiver, directly to the receiver, bypassing the receiver multicoupler, and then the software will automatically, once you tell it you're done reconnecting the setup, it'll reinitialize the test and continue. And here's the indicator saying to bypass the receiver multicoupler as shown on the figure of page 3. And when this is done, select the OK button here to indicate to the software that you've already reconnectorized your setup. And here's the figure. Here's where we bypass the receiver multicoupler. We go directly to the receiver cavity filter input to perform the rest of the checks. And again, this deals with the RF levels required to perform the checks that are remaining, which is the audio, selectivity, and ABC action. Once you're done, then you come back to page 2, select the OK button, and this will allow the software to continue to perform the rest of the checks, which will be the audio output level check, the selectivity, and the ABC action check. Once the checks are complete, the results will display as shown here. Now all that's left to do is for you to record the measured values on the appropriate TPR form and verify that the recorded values meet the appropriate standards and tolerances. If need to, you can refer to the individual receiver check to adjust anything you'd like. Now on this save options, same as before, I'm just going to enter a example here, RTR OKCET. I'm just going to identify the radio as a main receiver. Here's my timestamp, and I'm going to enter comments here, initial checks as found values for this example. And again, this gives me a record of the values that were just performed and captured using this specific test equipment. And once I hit save, it writes the measured values in addition to all the site-specific information and radio configuration to a log. And now this note will be added automatically when using the alternate automated checks to indicate that they were used while performing these checks. And so again, another tool to capture how the checks were performed, what methods were used. We're going to close that save options, and if you wanted to adjust any of the parameters, again, you will go to each individual check and verify that you are set up correctly, because in some instances you're going to go through the multicoupler, and in some instances you're not going to go through multicoupler. So for example, here you do go through the front TP1 test port. If you need to adjust the audio output level, you bypass the receiver multicoupler. And again, this is only applicable to this alternate method, and just be familiar with when to do what and follow the diagrams to verify that your connections are made in accordance with the check that you're trying to do. I'm going to close here, and to close the alternate method, just toggle the selection here. The last thing I'll touch upon here is the measurement logs option. This button allows you to query existing measurement logs by clicking on that folder icon. Here's the measurement log we just created today. And so once you select the file, you go to step 2, select open file, and then you can review all of the logs that have been logged for that day. And as you see here, here's all of our information, our notes, and our comments. Close the measurement logs option by clicking on the measurement logs button. And again, once we're done doing maintenance, we want to click on the DHCP enable button to launch the script that will automatically reconfigure our network port for connecting to the FAA network, or for using that port to connect to the internet. And then we can close the Comm App application by clicking on that button. And if you have any questions, don't hesitate to call us.